Scene script. Have you ever wondered what would happen if an asteroid hits the Earth? Asteroids, these mysterious celestial bodies, have captured the imagination of science enthusiasts and doomsday predictors alike. Originating from the asteroid belt, a region of space located between the orbits of Mars and Jupiter, these space rocks are remnants from the early solar system. They are essentially cosmic leftovers, pieces of rock and metal that never coalesced into a planet. Their sizes can vary dramatically, from tiny pebbles to massive rocks spanning miles in diameter. The largest asteroid in our solar system, Ceres, is so big that it's classified as a dwarf planet, with a diameter of about 600 miles. Now, consider this. An asteroid impact on Earth can be likened to a cosmic bullet. A small, seemingly insignificant object hurtling through space at unimaginable speeds, with the potential to cause massive devastation upon impact. It's a chilling thought, isn't it? But before you start preparing your doomsday bunker, let's talk about the odds. Luckily for us, the chances of a large asteroid hitting Earth are astronomically low. Think about it this way: you're more likely to win the lottery, get struck by lightning, or become a movie star than to witness a catastrophic asteroid impact in your lifetime. That's because our planet is just a tiny speck in the vast expanse of space, and asteroids, despite their numbers, are scattered over an even larger area. The odds of these two bodies meeting in the cosmic dance are, thankfully, incredibly slim. However, as low as these odds may be, they're not zero. The universe is a place of infinite possibilities after all. Now imagine, despite the odds, an asteroid is on a collision course with Earth. What happens next? As the asteroid approaches, it wouldn't be visible to the naked eye until it's alarmingly close. Picture this: a cosmic bullet hurtling through the void of space, unseen and unstoppable. It's a chilling thought, isn't it? But why would this be the case? The asteroid's visibility depends on a number of factors. Its size, of course, plays a significant role. The larger the asteroid, the earlier we would be able to see it. Its speed also matters. A faster asteroid gives us less time to spot it. But perhaps most importantly, it's a matter of light. Asteroids do not emit light of their own. They're visible only when they reflect the sun's light. And the farther they are from the sun, the dimmer they appear. So, could we detect an asteroid before it becomes a visible threat? The answer is, thankfully, yes. We have technologies and techniques designed for this very purpose. Space agencies around the world use powerful telescopes to scan the skies, looking for objects that might pose a threat. These early warning systems have a good track record, but they're not perfect. Smaller asteroids can slip through the net, and even larger ones can catch us off guard if they come from the direction of the sun. Upon detection, the scientific community would spring into action. Astronomers would calculate the asteroid's trajectory, trying to predict its path and potential impact zone. This information would be shared with governments and international organizations, sparking discussions about possible countermeasures. And what about the general public? Well, reactions would likely be mixed. Some would be fascinated, following the news with bated breath. Others would be fearful, apprehensive of the impending cosmic event. And of course, there would be those who simply wouldn't believe it, dismissing the news as a hoax or an exaggeration. The asteroid is now seconds away from impact. The Earth holds its breath. As the world turns its eyes skyward, we wait and we wonder, what will happen when the cosmic bullet strikes? And then, impact. The moment of collision is like nothing the Earth has ever experienced. Let's visualize this, shall we? Imagine the asteroid, a colossal cosmic bullet, slamming into our planet. The sheer force of this collision releases an unimaginable amount of energy, equivalent to billions, maybe even trillions of atomic bombs. This energy is so intense that it vaporizes the asteroid and a substantial chunk of the Earth's crust upon impact. Now picture the ground beneath the impact site. It's not just a hole, it's a massive crater, larger than any city on Earth. The force of the impact is so immense that it literally liquefies the ground, creating a temporary ocean of molten rock. But the spectacle doesn't end there. The asteroid's arrival is so violent, so cataclysmic, that it catapults tons of debris high into the atmosphere. These aren't just rocks and dust, we're talking about superheated blobs of molten rock and metal. Some might even escape the Earth's gravitational pull and be flung out into space. However, most of this debris won't get that lucky. Instead, it falls back down to Earth. These falling fragments, still glowing hot from the impact, would set the world aflame, igniting wildfires on a global scale. Imagine the sky raining fire, a sight both terrifying and awe-inspiring. And the shockwave. The impact would send out a shockwave that would flatten anything in its path. Buildings, trees, hills, Nothing would stand in the face of this unstoppable force. This shockwave wouldn't just be felt locally, it would circle the Earth multiple times, causing destruction with each pass. And the sound, oh, the sound, it would be deafening, a thunderous roar that would echo around the world, a grim reminder of the cosmic bullet that just struck our planet. The initial devastation is immense, but the aftermath of the asteroid strike is even more catastrophic. In the aftermath, the Earth is a drastically different place. The impact of an asteroid leaves scars that stretch far beyond the initial crater. It's a cosmic event that alters the very fabric of our planet's environment and ecosystems on a global scale. Imagine, if you will, the Earth's climate undergoing a radical shift. The immense heat and energy released from the asteroid's impact would send vast amounts of dust and debris into the atmosphere. This thick cloud of particulates would envelop the globe, blocking out sunlight and plunging the Earth into a prolonged period of darkness and cold. This is the chilling scenario of a nuclear winter. Such a significant drop in temperature would have far-reaching effects on our planet. The cold, dark conditions would cause a sharp decline in plant photosynthesis, disrupting the delicate balance of our food chain. From the smallest microorganisms to the largest predators, every living creature would feel the effects of this change. A nuclear winter could last for years, even decades. During this time, the Earth's ecosystems would struggle to adapt to the harsh new conditions. Some species would inevitably perish, unable to cope with the sudden change. This could potentially trigger a mass extinction event, similar to what scientists believe happened to the dinosaurs around 65 million years ago. Yet, amidst this bleak scenario, life has a way of clinging on. Some species, particularly those that can adapt quickly or have broad diet ranges, might survive. Deep-sea creatures, for instance, that rely less on sunlight for survival, could endure. However, the road to recovery would be long and fraught with challenges. Even after the nuclear winter subsides, the Earth's ecosystems would be forever altered. It would take millions of years for biodiversity to bounce back and for the Earth to regain its full vibrancy. Life on Earth would struggle to survive, but it's not the end just yet. Despite the catastrophic effects of an asteroid impact, life in its myriad forms has a remarkable ability to persist. The aftermath might be devastating, but as history has shown us, life finds a way. Despite the cataclysm, Earth has a remarkable ability to recover. It's a testament to the tenacity of life that, even after the most profound disruptions, our planet has shown time and again its capacity to bounce back. Let's delve into the potential for recovery after an asteroid impact. The first thing to understand is that life, as a rule, is incredibly resilient. After all, life on Earth has survived 5 mass extinctions, each one a catastrophic event that wiped out the majority of species. Yet after every wipeout, life bounced back, often in more diverse and complex forms. Take, for instance, the asteroid that hit Earth some 65 million years ago, ending the reign of the dinosaurs. It was a disaster, yes, but it also opened up ecological niches that allowed mammals, our ancestors, to flourish. Similarly, an asteroid impact today could, over millions of years, lead to the evolution of new species that we can't even imagine. But what about human survival? It's hard to say for sure, but humans have shown remarkable adaptability throughout history. We've survived ice ages, droughts, and countless other challenges. It's entirely possible that with enough warning, we could prepare for an asteroid impact. We may need to live in underground shelters for a time, or even establish colonies on other planets. But the important thing is, there's a chance. Of course, this is not to minimize the devastation that an asteroid impact would cause. Millions, if not billions, of lives would be lost. Ecosystems would be destroyed, and it might take millions of years for life to fully recover. But the point is, recovery is possible. Life has a way of enduring, of finding a way, no matter how bleak the circumstances. So, while an asteroid impact would be a disaster of unprecedented proportions, it's not necessarily the end of the world. It would be a new beginning, a chance for life to evolve and adapt in ways that we can't possibly predict. And that in itself is a testament to the remarkable resilience of life on Earth.